Hello everyone. Well, you're getting pretty close to the end now. This week you'll be covering Chapter 9, Local Area Network Operating Systems and Remote Access. In the early days of networking, the Network Operating System, or NOS, was an add-on component to existing computer operating systems. Most of the early network operating systems were proprietary, which limited their ability to communicate with computers that were using network operating systems from other manufacturers. These days, network operating systems are much more open and support the idea of universal clients, which can communicate with other clients and servers regardless of the NOS that they are using. Generally, network operating systems fall into two categories: peer-to-peer and client-server. Peer-to-peer networks are networks of computers that don't usually include a dedicated server. Instead, each computer is usually running some sort of desktop operating system which is designed to share file and printer resources with each other. Even though in corporate networks these days they are generally using client-server enterprise models of networking, the computer operating systems, whether they are running Microsoft Windows, Macintosh OS, Linux, or even Unix, those operating systems are capable of both requesting services from the network as well as providing services to the network. In a peer-to-peer configuration, the network operating systems are configured to do both. In a client-server environment, they're configured strictly as a client, which only makes requests that are then responded to by dedicated servers, which are usually housed in specialized server rooms. Peer-to-peer networks are designed as low-cost workgroup solutions. When they provide services, it is usually only file sharing or print sharing services. One of the major drawbacks to peer-to-peer workgroup networks is their lack of ability to provide centralized authentication and authorization, which we'll discuss in greater detail in Chapter 12. Peer-to-peer networks also don't scale well. That is to say that the more computers that are added to the network, the less efficient the network services become. This is due to the fact that the client operating systems are optimized to run desktop applications, whereas the server operating systems are optimized to provide network services. In this slide, you can see a table that has the functional requirements of today's network operating systems, where in the past, traditionally, the only requirements really were file services and printer services. Now we have application services, directory services, and integration migration services that are being required of the network operating systems. And we'll discuss each one of those in details later on in this chapter. This graphic shows the traditional client-server network operating system. Basically what it's depicting is the workstations on the left, which have the client portion of the network operating system. We're communicating with the servers on the right, which consisted of the server portion of the network operating system. And in this example, again in the beginnings of early networking, early client-server networking, they were pretty much running the same operating system on both sides, both on the client side and on the server side. Although when Novell had their network operating system released, it was strictly a server operating system, and they did use Microsoft Windows on the desktop for their client operating system. So this was mainly used in what they call departmental solutions. You'll also hear it referred to as work groups. And so again, an early example really of client-server network operating systems. This graphic then reflects the change that has occurred, where the client network operating system is completely independent of the server network operating system. So you can be running Mac OS or Linux or Windows or Unix as the client operating system, and you can be running any of a variety of different server operating systems as well, like Windows Server, Linux Server, Unix servers, or even Mac servers. And so this is referred to as an enterprise solution. It's a heterogeneous environment, meaning that we have a mix of different types of operating systems, all capable of communicating with each other. You'll notice the clients are also referred to as universal clients because they're able to access all different types of servers. And then the servers themselves are multi-protocol servers because they're able to support many different protocols, which is both the network protocols, like at the network layer. Novell had the IPX SPX protocol, and then of course these days most modern day networks are all using TCP/IP. Microsoft in the early days also used NetBEUI and NetBIOS. Also IBM systems were using NetBIOS. But these days, pretty much everybody runs TCP/IP at the network layer. But it's also important at the session layer that both the client and the server are running the same protocol at the session layer for file access. Now, when you're getting into like web services and FTP services, it works quite a bit differently. That's happening at the application layer. And as long as the client has an HTTP web browser, an FTP client, SMTP mail client, then they can always communicate with the server side of that pairing. So as long as the server is running SMTP, a mail client can communicate with it. As long as it's running a web service, HTTP services, the client again can, if they're running an HTTP browser, can communicate with that server. And so that's why a lot of the benefits of TCP/IP are that it provides us with a lot of these application layer APIs that make it possible for a multitude of clients to be able to communicate with any type of server network operating system. Because the client and the server platforms have been decoupled, server network operating systems now can be selected based on their performance characteristics for a given function. In other words, whether they're a web server, a mail server, an FTP server, a database server, or a directory services server. And there's many other possible types of servers as well. And so when you're looking at purchasing the server hardware now, we can determine the appropriate choices of CPUs and space, hard drive space, memory, amount of memory that's installed, all based on the performance characteristics of a particular type of server, because each server has different needs as far as its hardware resources are concerned. So as we mentioned to you earlier, the client workstation's ability to interoperate transparently with a number of different network operating system servers and without having to have any additional products or configurations breaks that traditional hard linkage between the client and the server network operating system. So that ability is commonly referred to as universal client capability. In the next couple of slides here, we're going to take a look at what the needs are as far as a client network operating system is concerned. And this graphic then shows you, if you look at the types of connections that they're indicating here, the solid lines represent peer-to-peer network connections, and the dashed lines represent client-to-server network connections. So you still might be sharing some files or a printer from a workstation, a client system, although as far as files are concerned, it's really best that they are stored on a server, because by centrally storing everybody's files, it makes it much easier for the administrator then to back up those files on a regular basis. If they're distributed out amongst multiple workstations, that can make the backup process much more difficult. So certainly when you look at a client network operating system, you're looking at various capabilities that that operating system has in relation to the client's needs. And you're still going to consider, as I say, perhaps the peer-to-peer networking capabilities. For instance, they might be using instant messaging so that they can communicate across the network. And then also, of course, the client software for communicating with all the various network servers that are existing out there on the network. So these are the main considerations as far as a client network operating system goes, the capabilities that you would be looking for. So the first thing is it a 32-bit or a 64-bit operating system? And again, the choice is going to be based on what the client's needs actually are. Not everybody necessarily needs to have a 64-bit operating system. If they're not doing video editing, any kind of high-end 3D animation or anything like that, then more than likely if they're just using Office and email and web browsing, then a 32-bit operating system is going to be more than enough for their needs. You also want to take a look at preemptive multitasking as a feature on an operating system. Most of the modern day operating systems now all feature this. Previously it was called cooperative multitasking, or at least that was the previous method that was used, and the reality was it wasn't very cooperative. One program could lock up the whole system if it didn't release access to the CPU to back to the operating system properly. And so the newer method of multitasking is called preemptive multitasking, and that way the operating system actually is controlling when the different applications that are running have access to the CPU. So that's definitely something that you want to be looking for. Also protected memory space, where each application has its own memory space so that a poorly written application can't accidentally overwrite the memory space of another application. And also symmetrical multiprocessing. This means the ability to run more than one CPU. And the operating system, and if you're going to run multiple CPUs, has to be able to support that. Again, most modern day operating systems do support that. And so you really don't have to worry about it. If you're going to buy Windows anywhere from XP up through Vista up through Windows 7, all of those versions have support for symmetrical multiprocessing. On the Mac side, OS X has support for it as well. Multi-threading is also important. This is the ability to actually have multiple threads process. See, a CPU normally only processes one thread at a time. Now when you get into some of the dual-core and quad-core CPUs and in hyper-threaded CPUs, they can process multiple threads simultaneously. And of course, if you have multiple CPUs, symmetrical multiprocessing that we just talked about, if you have multiple CPUs, then you can do multiple thread processing as well. So the operating system has to support that, and the application that you're running has to support that as well, in addition to having multiple cores or multiple CPUs running on that computer. You may need to have support in your operating system for older applications, what are known as legacy applications. So many times in corporate America they have applications that actually have been written in-house, and so you want to test out and make sure that those applications can run on any new operating system that you're considering purchasing. And of course, if your business is solely dedicated to using a particular application, and the business won't be functioning very well if that application doesn't run on the new operating system, then again, certainly that's a consideration, is to make sure you check out any of these older applications that are necessary for the continued operation of the business before you upgrade everybody's operating system and then find out it doesn't work. And of course, plug and play in modern operating systems is all supported. Now you do need to have three components in place for plug and play to work. You need to have a plug and play BIOS, so that's the hardware on the computer, plug and play operating system, and your devices that you're using have to be plug and play compliant as well. So as long as all three things are in place, then you will have support for plug and play. Also, device drivers are also going to be important when it comes to choosing your network operating system. Without drivers, your hardware isn't going to work, so you need to have drivers to communicate between the hardware and the operating system. And the older drivers, called the real mode drivers, won't be supported on the newer operating systems. And so the newer way of doing things is what we call virtual device drivers, or VXDs. And the advantage you get, if you look at this graphic here closely, you'll see that on the left there, the old way, the real mode way, was that the application was using the driver, and the driver then had direct access to the hardware. And so again, if we had some sort of problems with the code, then it was a good chance that it would lock up the system. So in the VXD, the virtual device driver methodology, the application program has to communicate with the network operating system, which then communicates to the driver, which communicates with the hardware. And so that's a much more reliable way of using drivers. So all of your 32-bit operating systems pretty much operate this way, using the virtual device drivers. And of course that includes Windows XP, Vista, Windows 7, Mac OS X, and those are all 32-bit network operating systems. And of course also now 64-bit operating systems are available for those as well. and they all prevent direct access to the hardware. So they all use VXDs. They won't be able to support, if you have older hardware that only has real mode drivers and there aren't any newer drivers available, VXD drivers available, then they won't be supported on the newer operating systems. All modern day operating systems also have what are called subsystems, and this is the memory space that the applications, the programs on your computer actually run in. In the earlier operating systems prior to Windows 2000 in the Windows environment and prior to OS 10 in the Mac environment, they were using a shared subsystem. That meant that all applications were operating within the same subsystem. So if any one application crashed, that also ended up crashing the subsystem. Then all of the programs running in that subsystem were unavailable or essentially crashed then at that point in time too. So that was the old way of doing things. The new way of doing things now is that each application is run in its own individual subsystem. So that way, if one application crashes, it only affects itself and the subsystem it's running in and has no effect on the other programs and the subsystems that they are running in. This slide covers some of the peer-to-peer networking capabilities that you might be looking for. As we've talked about previously, the file, print, and perhaps even web services might be a consideration. You can have, most of the modern day operating systems have the ability to be actually a web server. Even if you've got just the desktop operating system, it does have web service capabilities. Now that's not if you have the home version. In the Microsoft world, you have to have at least the professional version of their operating systems to have support for web services. But those operating systems, without having to go up to the higher level and spend more money on an actual server operating system, you can, on the client operating systems, be running a little web server. And there are some limitations when compared to the full-blown web services that run on the actual Microsoft Server operating systems. And then the next category is workgroup applications. Really, workgroup is kind of a misnomer here. It's not that these applications can be shared across the network, which is generally what a workgroup application is. These are just simply, this list here is a list of applications you might want to look for that come with your operating systems. And pretty much all of these that we see here do come with the Microsoft operating system, and most of them also come with the Macintosh operating system. So things like terminal emulation, the ability to actually emulate the old dumb terminals that we used to use in the mainframe days. Calculators, clocks, games of course are real important in corporate environments. Paintbrush program, sound recorders, remote access software is certainly important. CD player, perhaps even a DVD player these days. If you're doing some sort of training on a computer, then many times the format is either a CD or a DVD. Backup software, which does come with most of the Microsoft operating systems, so that users can back up their own files. Phone dialer, if you're using some sort of a software that is going to control the phone and allow for dial-up and whatnot, then phone dialers can be handy. Performance and network monitors, those are all built in so that we can see if we've got any bottlenecks and kind of check out to make sure that everything's running smoothly as far as the hardware is concerned and the network. Diagnostic software, screensavers, which I really don't recommend using at all. They even in the newer operating systems still seem to be problematic and tend to lock systems up. So I just tell everybody, turn the power button off on the monitor. That's the best screensaver. And a lot of your power settings that you have these days too will allow you to have like inactivity for maybe 5 to 10 minutes and then automatically shut the monitor off for you. That's much better than actually using a screensaver. Web browsers certainly, so that you can browse the internet, and of course you can download web browsers for free, like Firefox. You go to mozilla.org and Safari and all those browsers. The new Google Chrome can all be downloaded for free from the internet. Internet telephony, if you're going to use the internet for your phone communications. Instant messenger client, if you're going to be using instant messaging between your users within the network environment. And faxing software, if you need to send or receive faxes. When it comes to the client's operating system's network capabilities, there are three distinct elements of the network functionality on the client. They would be, this is from the bottom up now, client software and network drivers. So we're talking about NDIS in a Microsoft world. ODI was an older method that was used in NetWare environments to create the interface between the operating system and the network card. And then number two is the network transport protocol. So that just means the protocol is operating at the network layer. IP is pretty much 99.9% of the time going to be the network layer protocol, but in some older environments, if they're still using Novell, you might find IPX. In old Microsoft environments, you might find NetBEUI and even NetBIOS. In Apple or Macintosh environments, you might find that they're using AppleTalk. But predominantly, almost all operating systems in use today and all networks are using TCP/IP at the network layer. And then item number three, which is your network redirectors. I had mentioned this to you earlier, that at the session layer that you need to have the appropriate protocol operating. And so in a Microsoft world, in order for a client to exchange files or access shared files on a server, a Microsoft server, you need to be running server message blocks, or the SMB protocol. In the Novell environment, they have the NCP, NetWare Core Protocol. In the Apple environment, they have the AFP, the Apple File Protocol. So it's just a matter of the client being able to communicate with the server for file sharing purposes mainly. And so at the session layer, they need to be running the appropriate application redirector. You can see this table here is actually a little bit outmoded for modern day operating systems, but everything that we talk about here for Windows XP also applies to Windows Vista and Windows 7. So the main comparison would be between the newer operating systems, XP, Vista, and 7, to the older Microsoft Windows operating system, the 9X environment, which is your 95, your 98, and the ME operating system. And then we also compare it to the Linux operating system here. So for application support, meaning the programs that you're going to run under the operating system, Windows XP and again Vista and 7 support 32-bit APIs. They also, if you get the 64-bit version of the operating system, will support some of the newer 64-bit APIs and programs that are out there. They also have backwards compatibility for some of the 16-bit applications. Back in the older days, before even 9X, when you had Windows 3.1, Windows for Workgroups, those were all 16-bit applications, and that was a 16-bit operating system, so the applications were all 16 bits. So what they do is they create subsystems that actually support the 16-bit environment for those programs to run in. And the application redirectors, this is again at the session layer, so NCP, SMBs, and then the file systems, FAT and NTFS. And I highly recommend that you run NTFS. FAT is pretty much a volatile file system. It's the files are easily corrupted. Actually, the index is easily corrupted, and so you end up losing files. Whereas NTFS is very secure. It's very reliable. It has a lot of features built into it that make it really one of the premier file systems of the day. In the 9X environment, you'll see that you don't have any support for NTFS. So if you do have older machines running older operating systems from the 9X era, then you need to consider that if you're going to be exchanging hard drives perhaps from one system to another. You can upgrade. You can take FAT and you can upgrade it to NTFS, but you can't take an NTFS and downgrade it back to FAT. In the Linux environment, they support the network file system, which is used a lot in the Unix environments, and then also the EFS, the extended file system. And then they do have a capability to support, at the session layer, server message blocks. The product that they use is called Samba, and that gives them server message block emulation so that you can use Linux clients to communicate with Microsoft servers, and you can use Microsoft clients to communicate with Linux servers. At the network layer, the transport protocols, and this really would be the network layer and the transport layer. Microsoft Windows XP has support for IPX, SPX. In Windows Vista and 7, though, I believe they have removed support for IPX, SPX. NetBEUI is still supported, You don't install it separately anymore, but it's been built into the OS, the functionality that used to be provided by the add-on component, the NetBEUI extender, NetBIOS extender user interface, has been built into the operating system. TCP/IP, of course, is a must. Used to have support for AppleTalk. That's no longer there, although you can purchase products from the internet that do, or third-party companies, really what I'm talking about there, that do give you the ability to install AppleTalk capabilities on a Windows computer, but again, it's not really necessary since Apple computers are also running TCP/IP these days. So when you look at the 9X environment, same thing's true for everything we just talked about for XP, and Linux environment, Unix environment is pretty much, has always been exclusively TCP/IP. They were the forerunners as far as running TCP/IP. And then at our Mac sublayer, which is the bottom sublayer of the data link layer, this is where we integrate the operating system with the network interface card. And so in the Microsoft environments, we're going to use NDIS, which is your network data link interface. And that's true for 9X, XP, Windows 7, Vista. Then they used to have support in the 9X environment for ODI because there was a lot of 9X computers that were used for as clients in the Novell environments. Novell's still out there, but you don't see a lot of Novell networks anymore, so not too much of an issue. And then in the Linux world, they use a Unix kernel driver, and so that's specific, obviously, to the Unix systems, and so the hardware and the network interface card, as well as the operating system, have to all be able to support that. And if you're buying Linux and you've got Linux-based drivers for your network interface, then you will have support for that. So we move on to the role of the server network operating system now. As it says here, application services have become one of the most important criteria in server network operating system selection. So when we're talking about application services, we're talking about the server having or becoming a database server, a web server, a mail server, things of that nature. And so if you look at the right-hand graphic, or the right-hand portion of the graphic here, you see they list database and transaction process monitoring and directory synchronization. We're going to talk about domain controllers here in a little bit, which is the support for directory services. And so those are just examples of different types of applications that normally would run on a server. And so the server has what is called the back-end component, usually in a client-server environment. So if you have a mail server, for instance, then the client side is going to have the mail client that connects to that mail server for the receipt of mail and the sending of mail. And so anytime you hear client-server, that's what they're talking about, is that the graphical interface is on the client side, and the gives the client the ability to make the connection to the server and retrieve the information that we're trying to access from that server. So in the case of a web browser, you're trying to access web pages from a web server. In a mail client, you're trying to access mail or send mail through a mail server. Then the client network operating systems, as we said, can be just about any network operating system today, as long as the network transport layer and the session layer have the same protocols in operation. The server side, we want to make sure that we have communications and messaging. So like again, if you have certain types of communications or messaging going on, like instant messaging. And then at the bottom layer there, you've got your hardware, which of course is the network interface card, and as long as we're both running Ethernet, we can communicate to each other, and that's not really absolutely necessary either. I mean, you can translate Ethernet to token ring and vice versa. Most networks are going to be running your token rings, as long as we're talking about local area networks. Of course, there's a whole slew of protocols that operate out there in the wide area networks. We're going to talk about directory services now for just a little bit. It's very important you understand the concept of directory services and kind of the comparison to the old way that things were done, which was domain-based environments. And I shouldn't say domain-based, because I mean even directory services are still domain-based. But in the older days, we had primary domain controllers and backup domain controllers, and the whole idea of the domain, as is the same idea with directory services, is that we're trying to create a server that has a database where we store all of the usernames and all the properties with regards to those users, like what their passwords are. We can also organize them into different groups. And so when a user logs onto a network, they actually then send that logon request to the domain controller. The domain controller looks up the user information and performs the authentication process, as opposed to them logging on to their local computer, the one that they're actually sitting at. And so that gives us a centralized capability, because in a workgroup environment you have user accounts on each individual computer. But the problem is if a person is trying to share files or folders, for instance, then the person who is sharing the file or the folder has to be the administrator of that computer and actually set it up so that other users will have accounts on that computer, and then assign the account the level of permission they want them to have to the particular file or the folder that they want to provide access to. So it just puts a little bit more burden on the individual user. It's much, and every individual computer in a workgroup environment is going to have their own database of users. So it's just much better to centralize the whole thing and then have an administrator in charge of keeping track of all the user accounts and whatnot. In very large environments, we actually delegate that. You have you have the administrator of the network, but then you have people that work underneath of the administrator, and so we can delegate and assign particular people to just simply manage user accounts in very large environments. The other issue is the resources themselves, the folders, the files, the printers, and many different possible resources actually these days. And we need to provide access anyway to those resources by assigning, I should say, the user account some level of access. So there's two things that we really talk about in much greater detail in Chapter 12, and that's authentication and authorization. So you need to understand briefly that authentication is just the task that is performed to verify the identity of the entity, meaning we want to verify the user that is trying to log into the network is indeed that user. If you think about when you go and write a check at a store, many times they ask for your driver's license, right, so they can verify that that's actually you. Well, in a network-based environment, what we do is we have three different methods. One is one you probably are very familiar with, typing in a user account name and using a password. So that method is what we know. As long as you know the username and the appropriate password that corresponds with that username, then you're going to gain access. You'll be authenticated and gain access to the network. The second method is what you possess. So they have what are called smart cards that we can swipe. You've probably seen smart cards used in doorway access many times, where they have a magnetic stripe on them with all of the user account information, and they just simply swipe the card through the reader to gain access to a particular facility. So that's what you possess. And then the third thing is biological, which is what you are. We can do thumbprint scans, we can do retinal eye scans, things of that nature to actually verify the identity of the entity. So that's all three methods. They're all just different ways of providing for authentication, verifying the identity of the entity. Authorization is once we've identified the entity, we make a decision as to what level of access that person or user has to a particular resource. So that's authorization. Do they have read-only access? Do they have read and write access? Do they have the ability to delete a file, for instance? That's all levels of authorization. So understand the difference between authentication and authorization. As I say, in Chapter 12, we'll go back over this again in a little bit greater detail. So, as I was speaking of directory services, we were saying that there's this domain controller, the old days primary domain controller and backup domain controllers. The primary domain controller maintained the list of all the users and the resources that were available in the network, and then distributed that out to the backup domain controllers in case the primary domain controller, the PDC, were to go down or be unavailable. These days, in the newer directory services method way of doing things, there are domain controllers, but there is not a primary domain controller. Each domain controller is capable of modifying the user information and storing information about the resources, and then all domain controllers share their information with all other domain controllers operating within a particular domain. So that has changed quite a bit. It's a distributed system now, whereas previously we had a single system that was defined as that primary domain controller. So your publisher of this particular book, the way that they separate out the two, they refer to the old way as domains and the new way as directory services. So it gets kind of confusing because, as I say, directory services do organize the resources into domains. That's still an organizational component of directory services. It's just in the older days, you would set up a domain and you would have all these users and all these computers as a member of a particular domain, and it was much more difficult than it is today with directory services to be in the domain days of sharing the resources from one domain to another domain. You had to manually set up these inter-domain trusts that would allow users from one domain to have access to resources in a different domain. They were also referred to as flat file databases. They weren't hierarchically structured as the new directory services databases are. And so you have a lot more capability, flexibility with directory services. They're distributed and they're hierarchical, and that means that they scale better, meaning that the network can grow much easier. We can continue to add domains and subdomains, whereas just the old way was very difficult, not very scalable at all. So again, directory services just organizes all network user and resource data into a single hierarchical database, and it provides a single point of user and resource management. Even though it's distributed among multiple servers, as an administrator you log on to a domain controller and you have access to all of the information as far as the domain is concerned, all of the users and all of the resources. And then if you make a change on that particular domain controller, that domain controller then is going to distribute that change out to all the rest of the domain controllers. So all of the servers then that participate in the directory are part of a global hierarchy, and they can see all other parts of the network. Some examples of directory services would be Novell's NetWare Directory Services, NDS, and Microsoft's Active Directory, or AD. So when you hear Active Directory, just know that that's Microsoft's brand name for a directory service server, or the directory services software that Microsoft provides. Domains then in a modern day directory services based network are a way of organizing the resources. So all users and computers might be a member of domain A, and then another group of users and computers will be a member of domain B. And so the resources are organized based on what we would call a security boundary that is known as a domain. And so the way you establish a domain is you have to have at least one domain controller that is operating within that domain, because it's going to store all of the user and resource information for that particular domain. And so each individual domain's directory has to be individually established and maintained. So you would have an administrator for each domain. Depending on the environment, you actually could have one administrator that controls many domains. In fact, in the Microsoft environment, you have what is called the enterprise administrator, which in a multi-domain environment, the enterprise administrator is actually capable of accessing and making modifications within the individual or the separate domains. Domains can be individually maintained, as I said earlier, with their own administrators, and controlled in terms of how much the other domains can be seen. So we can isolate all of the resources within a domain, and so that they can only be used by the users in that domain, or we can also loosen things up a bit and make it so that some of the resources are available to users in other domain as well. In this case here, they're referring to now the older technology, the older way of doing things. So in the older domain-based environment, the key weaknesses were that it was limited in its granularity. In other words, we couldn't break it down into smaller chunks very easily. And you were either in the domain or you weren't in the domain. And there was no hierarchical structure. As I mentioned to you earlier, it was a flat file database. And so if you can think of like a phone book, that's like a flat file database where you start at A and you work your way to B, C, D, and you go item by item until you find what you're looking for, as opposed to a hierarchical database which starts with a single point at the top and then branches off to 2 or more points. So if you think about how that's working, you are reducing the number of items at this next layer down by at least 2. See, if we got a single point and then we divide that into 2 separate points and then divide again by 2 separate points, you're actually expediting how quickly we can look things up in the database. Some examples of the domain solutions would be Windows NT. That was a domain-based environment. In fact, it was Windows 2000 was the first time that Microsoft introduced their Active Directory services. So prior to that, we had the Windows NT environment that was strictly the older domain method of doing things. And then Samba too, which is an add-on component for Unix, and it was designed to interoperate within NT environments, and so it also supported that old structure. So we've talked a little bit about application services before. These are a few considerations with regards to application services, especially as the network grows. As it gets bigger and bigger and you got more and more users placing demands on your servers, then it's really important that your servers are able to handle those demands. And so CPU and the number of CPUs is real important in that area, because remember, a CPU can only process one thread at a time. If it has multiple cores, then we can process more threads. If it has multiple CPUs, we can process more threads. So on servers, it's really important to obviously be able to process many threads simultaneously, because you're going to have many users accessing and attempting to get resources from that server at the same time. So also the users and their sophistication of the applications are growing, and so the only real solution is to be able to utilize more processing power. So again, it's just a matter of the ability to add CPUs or use CPUs that have multiple cores, and then if you add hyperthreading in there, then every time you have hyperthreading, you're doubling the number of cores that are already in the CPU. On file servers, then we're looking at a really disk-intensive type of application, and so the application programs are requesting services that use APIs, so that certainly is going to use a certain amount of CPU. The network operating systems also are going to vary in types and the number of supported file systems. We looked at that in a chart a little bit earlier on. In the Microsoft world, you're going to use NTFS. There's just no other well, there are other choices. They're not good choices. So NTFS is the way to go there. In Mac and Linux and Unix, they've got their own file systems as well. Some network operating systems can have multiple partitions on a disk drive and support multiple file systems. So you might actually see that in some environments. Not real important. I mean, if you think about how a file system works, it's a matter of the operating system attempting to access a file on a hard drive. So if it's on a desktop, then whatever that operating system is, you're going to use its file system to access the hard drive. If it's on a server, it's the same thing. So when the client comes across the network to access a file on the server, it's the server's operating system that is using the file system to grab the files. It has no impact whatsoever what the client's file system is at that point in time. As long as that client can communicate at the session layer with the server, then the server will use its file system to go grab the file and then send it back to the client. Other file services offered by the operating systems include file compression utilities. So that's obviously a good thing, so that you can get more files in a smaller amount of space. We also talked earlier about the servers being able to support various and a multitude of network clients out there. And so some of those would be the Windows 9X ME environment, or the Windows NT, XP, Vista, now Windows 7 environment, Macintosh OS, Unix. The key again is really two things. They both need to be using the same network transport layer protocol. Most likely that's going to be TCP/IP. And then the next thing would be for file services at the session layer, that they're both using the same session layer protocol. And so we're talking about the Apple file protocol on the Macintosh system, the server message blocks on the Microsoft system. And it's, as long as those are in place, then the clients will be able to communicate with the server. When you're getting into some of the other applications we've talked about, like SMTP for mail, email, and web services, HTTP, and FTP services for exchanging files between client and server, those, as long as they're running the TCP/IP protocol suite, those are all going to be supported on the client and the server. So if they're both running TCP/IP, you automatically have support for FTP, SMTP, HTTP, and a lot of other things like DNS and DHCP as well. On this slide here, we've been talking about this pretty much all the way through this particular chapter. Just beating a dead horse at this point. So TCP/IP is pretty much the network protocol of choice. Now, the one good thing that they do point out here that we haven't talked about is the support for multiple network interfaces on a single server. Certainly that helps to increase the number of clients that a server can support on the network. And so that's called a multi-homed computer. And it's a good idea if you've got a large enough network and a huge amount of clients that need to access a particular server, to give it, or make it, to install on it multiple network interface cards. I was looking at some computers the other day, some servers that had like 8 network interfaces built into them. So it definitely gives you an advantage as far as the number of clients that can be supported simultaneously from a server. Another capability that you might need in your network operating system would be remote access and gateway services. So remote access gives remote users the ability to connect to the network from a remote location and have access to various resources. Gateway services can be things like VPNs, virtual private networks, where you create a secure connection between the remote user and the network by actually encrypting the data that's being sent and received by both devices. Gateway services can actually even translate the network layer protocol. If the client, for instance, comes in on TCP/IP and the internal network is an older, maybe Novell network using IPX/SPX, it can actually repackage the TCP/IP packets into IPX packets and then forward them onto the network, the local area network. And so just another feature that you might be considering when you consider your server network operating system. As the slide says here, the remote access service might be part of the network operating system, as it is in the Microsoft server network operating system. And in some environments, some operating systems, it's not included, and so you buy it as a separate component and you install it just like you would install any other application on a computer. So RAS or RAS, remote access servers, have to be tightly integrated into the server network operating system to assure reliable performance, full functionality, and tight security. Other features that you might look for in your network operating system would be things like auto detection and configuration of your installed controllers, interface cards, and peripherals. It's basically, we're talking about plug and play here, so just making sure that the network server operating system does recognize all the hardware that's installed on the box, the computer that is going to be the server. Also, the ability of the server network operating system to automatically configure a controller adapter or peripheral is dependent on the network operating system possessing a compatible driver for that device, and that's not absolutely true. In other words, the network operating system doesn't have to necessarily come with the device driver, as long as the manufacturer of the hardware provides a compatible device driver for that operating system. So a lot of times you can go to the manufacturer's site and find the most recent driver and as long as it's been devised for, written for the server operating system, then of course you can install that and be assured that it will work, or pretty much assured, not always, but pretty much assured that it's going to work with your network operating system. Also, integration and migration might be concerns when you take a look at purchasing a network operating system. Migration is mainly designed to convert the files that are stored on one server type, say a Novell server, over to the Microsoft server. In fact, Microsoft actually had software in some of their older server product that was designed specifically for that. When they were competing heavily against Novell, they had this migration services product that would actually take all the files from a Novell server and easily convert them for you and copy them and store them on a Microsoft server. One of the main concerns is the directory services information, which means the authorization information. So each file has what's called a descriptor that's stored with it, and that identifies all of the users and or groups and the levels of access that they have to that particular resource, because you obviously wouldn't want to have to go back and redo all of that. So if you're going to be migrating the files from a Novell system over to a Microsoft system, you would want all of that to be maintained, and that's what the migration services primarily did do. Integration refers to the transition period between the migration process, when both network operating systems are running simultaneously and interacting to some degree. I would also say that integration just means that in a modern heterogeneous environment that they just can all work with each other. So you can have Microsoft systems and Linux systems and Mac systems and maybe Novell systems, and they just all are working within the network transparently to the clients, to the users. From an administrator's perspective, one of the most important things is the ability to monitor the performance of your servers so that you can identify bottlenecks should they occur and know which component is causing the bottleneck. One of the things that we used to teach in the Microsoft Systems Engineer program was placing workloads on a server so that you could identify where that server was going to be lacking performance-wise. In other words, do we need to upgrade the RAM, have a larger hard drive, faster CPU, faster network card? And so obviously as your network grows and you have more demand being placed on that server, then you as the administrator will need to do that, need to be able to identify the component that is slowing the system down the most, and then of course make the recommendation to upgrade that component so that it will operate more efficiently. Security, of course, is a major issue these days. We want to make sure that our files and our resources are secure from those that want to steal our proprietary information, especially if we're doing a lot of research, and like Coca-Cola's got their secret formula. They certainly don't want that to be stolen. And in most corporate environments, that's going to be the situation. You're going to have accounting information and all types of information that needs to be protected from both employees as well as outside threats to those resources. And so again, we come back and talk about 3 ways of providing security within the network, and usually all of these 3 components kind of work hand in hand with each other to help tighten things up a bit. So we talked about authentication earlier. Remember, that is the verification of the identity of the entity. So basically the way of providing some form of user confirmation. That's what authentication is all about, making sure that the user that's trying to gain access is indeed that user that they claim to be. Authorization then is the level of access that they have to the resource. In the case of a file, you have read access, write access, the ability to delete the file. So those are all levels of authorization. Then encryption means that as the requests are being sent by the client, the responses are being sent back to the client from the server, that all of that transmission is encrypted or scrambled so that if anybody were able to actually capture the signal as it transported over the network, they would not be able to read the information that was contained within the correspondence, the messaging that was going on between the client and the server. Now we get into remote access, which is a pretty big component of most modern day networks. You have a lot of telecommuters out there, people who are working from their homes or from a remote facility and need to have access to the corporate network, the files and the resources there in the network. We also have mobile computers. Salesmen may be going out on the road, taking a laptop with them, needing to, while they're out on the road, gain access to the network, submit invoices back for different products that they are selling out there while they're on the road. And for technical support, so that you can have remote support occurring. You have a centralized corporate headquarters, for instance, and at a branch office somebody's having a problem with their computer, and so we want to be able to provide technical support without having to actually physically send a person out to that remote site. So there's a lot of reasons for having remote access. Those are the three main areas. One of the biggest issues with remote access has always been bandwidth. If you're used to working in a local area network environment, you're used to 100 megabit per second, or probably these days even gigabit per second network speeds. When we start using WAN links, however, those are going to be much narrower bandwidths. Depends on the type of connection we have. We have a T1 connection. We're talking about 1.5 megabits per second. If you're using DSL, you're talking about 1.5 megabits per second in one direction, and maybe 384 kilobits per second in the other direction. As you get to larger lines like T3s, now you're up to 43 megabits per second, and of course in the areas that have fiber now, we're talking even higher speeds. We're getting up there into the gigabit speed range. But that's always a consideration, is the type of traffic that you're going to be trying to access, the type of files. Are they video files, audio files, or database files, textual files, and how fast we can get access to them. So bandwidth is a big issue, obviously, with remote access. So in case you're not real clear on really what remote access is, this graphic illustrates it pretty well. Just think of it as a PC that would normally be in the local area network is now at a remote location, but still trying to have basically the same access to the local area network at the corporate headquarters. And so even when you get mail, a lot of folks these days get mail from web-hosted, internet-hosted mail servers, and so that's another example of remote access. You're going over a WAN link and gaining access to the server to provide you some sort of a service. In the case of remote access, it generally goes a step further, which is that you connect to the remote access server, and then through that server you can also get to other servers within the local area network. Now, remote control is a little bit different type of remote access. You need to have in the Microsoft world, we have the remote desktop client that connects to the server, and that's kind of like extending really the keyboard and the mouse. Because what the client is doing is able to remotely control. It's the same as if I'm sitting at the server and at the keyboard and the mouse in front of the server and doing whatever management, administrative duties that I need to do on that server. I'm just doing it remotely now. And so it's actually controlling the server itself as opposed to connecting to the server to use it to get other resources or to just even grab files from that server. Remote control, we're actually remotely controlling that server, and again, it's a good way to think of it. It's just you're extending that keyboard out there and the mouse out to that remote distance. Basically what happens is it doesn't eat up a lot of bandwidth. You are able to send keystrokes and mouse movements from the remote system to the server over the WAN link, and then what the server does is figure out what the keystrokes and the mouse movements are telling it to do, and then it captures a screenshot of what the changes are as far as the screen, the desktop screen that you'd be looking at, and then sends that image back to the client. And it is a very efficient way of of controlling. Most administrators these days don't actually physically go to the server to administer those servers. They actually just work from their workstations and use remote desktop client to connect to the server and manage that server however they need to. One of the considerations of remote access is how we make the connection from the client to the server. In the old days, it used to be more costly because we'd actually use a phone modem to dial up and connect to the servers directly. But with the advent of the internet, now the client can be connected locally to their internet service provider, and the server can be connected locally to its local service provider, internet service provider. And so there's no long distance charges that are occurring there. So each one connects to their local service provider and then uses the internet as the backbone to make the connection. So that certainly is a consideration. TCP/IP, of course, because the internet is TCP/IP based, is the predominant protocol that's being used also in this remote connection. And what you'll notice if you look at these graphics is that at the next to the bottom layer, the hardware layer, the physical layer there is the serial port or the network interface card, of course, internally on the case of the server. So the server has an external port which is connected to a modem, internal port which is connected to the switch that is the local area network and where all the other servers and whatnot are attached to. But look at the layer up from that and you'll see there's a PPP in there, and that's the point-to-point protocol. So that is the protocol, the communications protocol that's used to communicate between the two devices. And that's only one of several protocols that are used when we're doing remote access. You can also use the point-to-point tunneling protocol, PPTP. There's also another protocol developed by Cisco, which is the L2TP. But PPP had been very popular and predominantly used for many years. And some of these others are being used now because they're more secure protocols than is PPP, the point-to-point protocol. So here's an example then of using some of the more sophisticated modern-day communications protocols, the point-to-point tunneling protocol, PPTP or L2TP. You can actually encrypt the data from the remote client before it leaves the remote router or the remote modem, whatever we're using to make the connection to the ISP. And then it stays encrypted all the way through the internet until it gets received and at, in this example, corporate headquarters by the router there at corporate headquarters. And so because that data and that exchange of information between the client and the server is encrypted, then theoretically nobody can, or even if they were to steal the information, if they were able to grab the information as it traveled across the internet, they weren't going to be able to comprehend or actually see, what the information was, because it's in a scrambled format, an encrypted format. And most encryption these days is very difficult to break. There are some systems that are designed, to actually take messages that are captured and even if they're encrypted, try to break them. But the more bits you use for your encryption key, the stronger the encryption is, and most systems these days use at least 128 bits, if not more, which is very difficult encryption to crack. So anyway, using these encryption protocols for the communication process forms what is known as a tunnel. So that's just the tunnel represents the point at which the data is encrypted until the data is decrypted. And so again, at the sender it's going to encrypt, and at the recipient it's going to decrypt. And so the point in between there is referred to as a tunnel. And so when we have this encryption going on and we have the tunnel created, the entire process, the entire configuration there is called a VPN, or a virtual private network. This slide then just reiterates what we've just talked about. The VPN creates the encrypted tunnel across the public network, passes the data destined for the remote location across that tunnel, and the remote workstation gets a local IP address, and it appears to all computers on the local network as if it were local. So when the remote system makes the connection on the other end, then that connection on the other end is going to have a local IP address, so that the message can then be transported onto the local area network, and so we can gain access again to the resources there, which is in a remote access environment. That's what we're attempting to do. So here's just a couple of different ways of doing the remote access. The remote PC uses some sort of a connection to the internet. This graphic has a modem, but these days we're going to be using DSL or a UVerse connection or a FiOS connection or a cable connection to make the local connection to the ISP, and then the same on the corporate side too. They're going to have some sort of a high-speed link, most likely not going to be a dial-up connection. But the point is that in this particular diagram anyway, just the two different ways of making the connection at the remote site or the local site, depending on how you visualize this, because they actually have the client as the remote site. So at the local site, which would be the corporate headquarters, or wherever the company is located, wherever the LAN is located, right, the local area network. So anyway, one way would be to connect to just a PC running a standard desktop operating system. Pretty much all of the Microsoft Windows operating systems from 95 on have had the ability to provide remote access services. So in other words, receive the connection from a remote system. And then going through the desktop computer and through the switch that it's attached to, then it gains access to another resource in the network, in this case a local PC on that LAN, but it could be the file server that you see in the graphic there as well. In the second diagram, the only difference is that we actually have a dedicated communication server that provides that access to the local area network. And so you're going to get a little bit more sophistication, a little better security, more functionality, capabilities out of that particular communication server. This graphic then just shows all the different ways that we might connect the 2 points together, the remote site to the local site. And so in a dial-up situation, you're going to go through the public switch telephone network. There's also another type of a network that's a digital network called ISDN, Integrated Services Digital Network. And so you have to have a specific type of modem, an ISDN modem, to make that connection. If you're using a DSL modem, you're actually going over the public switch telephone network. And if you are using a VPN, in that any of these previous technologies, a modem, an ISDN, a DSL, and again FiOS, UVerse, cable, any of those technologies can be used in a VPN. The VPN again just simply means that we're encrypting between the two locations, and so as long as they support PPTP, and that's going to be done usually at the computer end these days. If you were going back to the modem technology, then the modem actually had to support that. And I think that was true with the ISDNs too. But DSL and routers, you're going through those devices, and so traditionally you're not going to have it. I mean, it just depends on the configuration and how things are set up on both ends. But the point being, you can use all kinds of technologies to set up a VPN. It doesn't have to be, as this graphic shows, a modem on both ends there. The key of a VPN is that you have devices capable of making the connection, but then in addition, we're able to encrypt the data from the sending point to the receiving point.